morning, everyone. Welcome to Utility Systems Technologies webinar on data centers. Over the next 20 minutes, we will discuss how some UPS designs and strategies actually increase the risk of outages and exposure to mains power or unregulated utility power, something no serious data center operator would consider using, by something that the UPS was not designed for, given the current utility conditions. To help us understand how we can reduce risks in the data center itself, reduce the risks of swells, sags, and outages, reduce data center operational costs by improving efficiencies, and extending the data center's useful life, we will hear from UST President Dr. Robert Deganoff and from UST Director of Sales and Marketing, Mr. David Whiteman. But before we get started, let me introduce myself and run through some quick housekeeping items to keep us on track. My name is Renee Devine, and I am part of the UST sales team responsible for managing key large accounts and marketing. For the next 20 minutes, we will hear from Bob and Dave on the importance of this topic, what it means to facility managers who are responsible for designing the operation and performance of facilities and the risks they face, and we will follow up on research and our recently published white paper to learn more about UST's approach to the solution. We will also learn more about the UST solution to help mitigate these risks, the ones I mentioned earlier. We anticipate the webinar will last about 20 minutes, followed by a short question and answer period. At this time, the phone lines are muted, and we ask that you please submit any questions using the GoToMeeting tools on the right-hand side of your screen. We will address these at the end of the presentation. Now I'd like to introduce you to Dr. Robert Deganoff, President of UST.
Good morning. Thanks for participating in the webinar. UST was founded in 1991. It was initially formed to design electronic on-load tap changers for utility applications. However, we recognized more interest in the market solving power quality problems, and that's really where we focused our efforts for the last 15 years. In the last 5 years, we've doubled our staff. We're a veteran-owned business, and UST manufactures over 100 units a year in sizes from 20 to 200 to 2,500 kVA. We have units in 49 of the 50 states. New Hampshire is the only holdout, and over 40 countries. I hope you find this webinar useful and educational. I'll now turn this over, the microphone over to Dave.
Okay, thanks, Bob. Again, I'll extend my my thanks to everyone for joining the webinar. We're going to start out by talking about the company and then the products that we manufacture. We have 3 core products. The flagship of the product line is the SureVolt, and we manufacture that product from 5 kVA up to 2,500 kVA, and we build the SureVolt in both 3-phase and single-phase applications. The sag fighter is a sag mitigation device, and we typically apply that product for larger applications, usually 100 kVA on up to 2,000 kVA. And then our third product is a small single-phase device. That's called the Mini EVR, and we manufacture that up to 15 kVA. As Bob mentioned, we're in over 40 countries. Obviously, a lot of the power problems that we encounter off the grid are happening in international markets. A lot of developing countries are still building their grids, and they're encountering voltage problems as they try to use more sophisticated equipment out in the field. Many of these countries you see noted here are the result of successful projects with the U.S. State Department, where UST has installed product at facilities within embassies throughout the world. Additionally, we've developed a fairly strong international sales channel and marketing campaign to promote our products on a global scale. So we've been fortunate to have a fair amount of success internationally. And obviously, since that's where most of the power problems occur, that's where we've had the greatest amount of success with our product. Here in the U.S., we face perhaps a little bit of a different set of circumstances when considering electrical distribution. We've got a grid that could be considered in a state of deteriorating mode. The loads are far more sensitive than they used to be with these electronic controls and such. We know that energy costs are going up. We have environmental regulations to deal with. And we also have some financial sensitivity, if you will. Financial considerations might be, the understanding that utilities are for-profit companies now, so they've got to balance the needs of their customers versus the expectations of their shareholders. As recently as 2013, the American Society of Civil Engineers gave the grid in the U.S. a rating of D+. So we know the grid is vulnerable, and that doesn't give manufacturers who invest millions of dollars in equipment much confidence in receiving good, clean power that won't put their equipment at risk. Utilities are forced to put a distribution strategy in place which attempts to target a nominal voltage. However, the ever-changing load demand and it makes it virtually impossible to meet the demands of all customers on a 24/7 basis. We've had firsthand knowledge of this experience with a client of ours and seen it in metropolitan areas. Recently, UST was involved with a project in Manhattan where a client was faced with high voltage, not low voltage, but high voltage, because there was such high demand in the metropolitan area in the summer when everybody's got their climate control systems and air conditioners cranked up, that the utility has no option but to stiffen the grid and run the voltage up in order to meet a sweet spot, if you will, during the course of the day when the demand is very high. At night, however, the voltage tends to run higher and it goes beyond tolerable levels, and that's where the particular client we were dealing with had a UPS system in place, and that system had to take action on a very frequent basis in order to work with voltage levels that were out of tolerance, if you will. So this is a common issue, and the problem lies squarely in the hands of the consumer, not with the utility in many cases. When we looked at the data center market, we did a fair amount of research and looked at this potential market. Many of the recent publications put out by key participants in the data center industry provided a tremendous amount of information and very useful information. And these were players such as Emerson, Eaton, Schneider Electric. They all have published papers out there that have thorough analysis of the data center industry. We also met with people as recently as within the past few months. We've gone out in the field and talked to design engineers who are designing data centers, and we actually confirmed a lot of the data that we found in our research. So let's look at data centers. The average size, they're about 12,500 square feet and consume about 2.5 megawatts. And it's pretty well known now, there's an estimate out there that there's well over 500,000 data centers worldwide. So obviously it's a big market, and it's growing. We know that data centers consume a huge amount of electricity in order to run their operations, both for the servers and for the air conditioning they need to maintain climate control within the facility. Very important. Because of this huge consumption of electricity, any gain we can provide in efficiency will relate to a savings. So it's important in our mind, anyway, to compare the efficiencies of the systems, because anything you can gain will result in a potential payback of the system. And the other thing we learned was 15% of unplanned outages at data centers are due to UPS failure. And the number one reason a UPS fails is usually has something to do with the battery system. We read all kinds of data about the cost of an unplanned outage. We ran across numbers that were $100,000, and we ran across numbers that were in excess of $500,000. So again, this offers an opportunity perhaps to present an alternative to current systems where there might be a significant payback. Is UPS the answer? Well, to an uneducated buyer, that might be the only answer they know of. In most cases, the owner of a data center turns to the UPS for power conditioning as well as prevention or ride-through through an actual outage. So typically, the most often used solution for mission-critical operations, like data centers, would be a UPS, and that only makes sense. We're by no means experts at the UPS product. We understand their place in the market, and we feel that we might offer a solution in some cases, not all cases, but we might offer a solution that might complement the functionality of the UPS and promote longer life and hopefully less downtime. There is an implied promise of uptime with the UPS. UPS manufacturers will promote their product to be not only the answer for a ride-through situation, but also to regulate voltage. They tend to be inefficient to a certain extent. I know this number, 93%, is something we used as an average in some of our analysis. I'm sure there's plenty of UPS manufacturers out there that will tell you that their systems run more efficiently, 94, 95, 96%. We've heard all those numbers. We don't disagree with them, but we're simply trying to demonstrate that if there is a difference in efficiencies of two systems, and you consider the consumption of electricity that these systems and these centers consume, there will be a cost savings. And typically, the premise behind the design of a UPS is risk avoidance. They're not so concerned about efficiency. They're more concerned about ride-through. So what does a data center owner do when he looks at protection? Well, we broke it down into three groups. You, of course, have redundancy, duplicate systems in order to make sure you have backups and such. You've got, of course, the UPS system. And typically, you might have a generator backup system as well. So depending on which level or tier of protection the data center needs, this will determine the redundancy and equipment required. How much are you willing to spend? How much risk can you tolerate? Cost versus exposure to risk. This is the thought process that must go through the planning behind a data center. So if we take a look at a typical arrangement with a double conversion UPS, it's pretty straightforward. You've got power coming in. You're going through a double conversion process with the UPS, and you're supplying the load. The double conversion systems might be accepted as the industry standard. However, they clearly sacrifice efficiency to avoid risk. Several manufacturers offer what's called an echo mode. Interesting concept. It provides far greater efficiency because now you're sending the power straight through to the load. unregulated, and you do gain some efficiency by doing so. What we discovered, though, is that most people who have purchased this don't implement this technology just because it might be difficult to tune. When does the UPS turn on? When does the UPS turn off? Different voltage characteristics based on site conditions. So what we generally found was that while this seems like a attractive marketing concept by promoting greater efficiency, that it isn't very well accepted in reality in the marketplace. So now we're going to take a look at the issues with a typical arrangement. Using the UPS as a voltage regulator will shorten the battery life. When that system is in place and the voltage goes out of tolerance or becomes reaches a level either high or low, sooner or later the UPS has to make a decision, and it's going to revert to its batteries to make that voltage correction. Anytime you use the batteries, you're sacrificing the life of the battery. We know, based on statistics and research that we've looked at quite thoroughly, that any given site, even in the U.S., is going to experience 40 to 60 events, electrical events, per year. But only 5 or less of those events are actually outages or a very deep, deep voltage sag. So the idea here is a lot of events are occurring out there, and it's taxing your UPS to make sure that your load is protected, but you're using the UPS as a power quality, power conditioning device to handle events that there might be a better alternative for. Referring back to the client we had in New York City, UST implemented a voltage regulator upstream from the UPS system to address out-of-tolerance voltage conditions, which were exercising the UPS on a frequent basis and contributing to shortened battery life. So you can imagine, on a day-in, day-out basis in New York City, air conditioners go on during the day, they come off at night, so the voltage is moving around quite frequently, and it's virtually a daily occurrence. The client now has a system where the voltage regulator conditions the power, as it's designed to do, to a tolerance of plus or minus 3% on the output, thereby relieving the UPS from day-to-day voltage regulation and allowing the UPS to be well prepared for an outage, should it occur. And as we stated earlier, remember 15% of unplanned outages are due to UPS failure. So what our alternative is to offer a voltage regulation product that takes care of perhaps 40 to 60 events a year that would have otherwise had to have been addressed by the UPS. So we've lightened the load on the UPS, and we've extended its life. So the arrangement might look something like this. You've got primary power coming through the UST Sure Volt, or the voltage regulator. The output of our device is plus or minus 3%. So now we're sending regulated power to the load 24/7. Very light duty for the UPS. And keep in mind, the UPS is typically only there for the 15 or 20 seconds it takes to bring generators online. So now we've presented an arrangement where the voltage regulator takes the bulk of the work in voltage regulation, and the UPS is there at the ready for any event that would occur beyond what the voltage regulator can handle in order to ride through the event and get the generators online. Again, very light duty for the UPS. So taking a closer look at the EVR, the UST SureVolt, just to give you some basic design characteristics. Our standard output is plus or minus 3%. We also offer a product where we can tighten that regulation to 2%. So depending on the application and the site conditions, we can provide very tightly regulated power 24/7 to the load. With an auto transformer design, we can operate at greater than 99% efficiency. So any efficiency we can demonstrate that's above and beyond or better than what the UPS offers could offer a potential savings. We have no moving parts, so it's essentially a maintenance-free device. We suggest a yearly inspection and cleaning. Other than that, there are no maintenance items to be concerned with the standard product. We've made the installation very simple. It's essentially plug and play. You wire your source voltage to an input breaker. We provide a terminal block for your load. As soon as you energize the unit, it begins regulating power. There's no startup procedures. There's no boot up procedures. As soon as you energize the unit, it begins regulating power. It's a very fast responding device. Because it is fully electronic, it makes corrections very quickly, far quicker than any mechanical device. And it's an industrial grade design. It's designed to go in factories. It's designed to be online 24/7. We also offer different types of enclosures based on the environment and the site conditions, whether you want to go indoors, outdoors, certain ambient conditions, all taken into consideration when we design and build the product. If you're interested in a more detailed financial analysis of this design approach, I will direct your attention to our website, where we have a white paper that goes through a very thorough financial analysis. And again, the key areas where we believe there's payback would be the cost of the outage. And again, that could be all over the board. It could range from, some sites will tell you that an outage costs them $100,000. Some sites will tell you an outage costs them $500,000. So we went through an example in the white paper, a very conservative example, to look at some of those costs. The other two areas of concern or justification from a financial perspective would be as I mentioned previously, the electrical efficiency of the difference between a typical design or standard design, if you will, versus a design that incorporates a voltage regulator. And there's also maintenance costs involved. All UPSs are sold with maintenance contracts. You've got batteries. You've got battery replacements. So the purchase of a UPS system requires an evaluation of the cost of the product over time. The UPS, or the UST product, the voltage regulator, is a one-time purchase. So you've got to look at cost, redundancy, and risk when you're evaluating all of these circumstances. The other thing I'd like to mention at this point is we are recording this presentation. So if you have any business colleagues that you think might find value in the material within this presentation, we will have it available through our website. So just to kind of circle back and summarize, we believe, or we have an approach to some data center systems, and again, we're not promoting ourselves as the cure-all to all systems, but we believe we can be promoted as an alternative that might complement a UPS, and will hopefully be in a design arrangement where we can cut UPS failure rates in half, perhaps by as much as 90%, depending on the circumstances. As mentioned earlier, we offer an electrical efficiency advantage. We're pretty confident that the arrangement will extend battery life because we're not going to use the batteries in the UPS nearly as much. And remember, the batteries are the #1 cause of a UPS failure. And we're going to minimize risk. When any data center design engineer or end user looks at the construction of a data center, obviously a key element is they want to minimize risk. So they're going to look at cost versus risk exposure. And if we can eliminate the need for the UPS to address 40 to 60 events per year, we believe we're going to minimize risk to some degree. That concludes the presentation. I'm going to turn it over to Renee, and if we have any questions at this point, Bob is still here and available, and we'll be happy to answer any questions.
So we do have quite a few questions. We'll start with the first one from Greg. Do you have any reference customers yet for data centers?
We're working with a company in New York City, as I mentioned in the presentation. We have a couple of other potential projects. We're just getting some traction in this area. We have over 900 units installed in the field worldwide. We'll be hitting 1,000 units this year. So we're in several different markets. Data centers is a little bit new to UST, simply because there seems to be some areas of that industry that are entrenched in certain designs, and so we're just trying to bring them an alternative that might be an option for them.
All right, thank you. So the next question is from Tom. So what are the typical battery replacement time and costs when you compare that to the UST EVR?
Well, what we would expect with the addition of the EVR, we would extend the battery life 20 to 40%. So if normally you'd expect to replace the batteries in 3 years, we would be able to extend that to 4 or possibly 5. And with that extension or reduction in cost, that would more than cover the cost of the EVR.
Okay. Is the unit in series with the incoming power? Is there a bypass? And is this automatic? And that's from John.
Well, the EVR would be in series, and there's an automatic bypass if something would happen to the EVR, it's automatically bypassed. So there's that configuration would actually put you in a similar situation as the echo mode for the UPS.
And this one's from Bob. Will adding an EVR to the UPS configuration change the mean time to failure?
If we add the EVR in parallel with the UPS, the bulk of the power will flow through the EVR, and the EVR's mean time to failure is considerably greater than the UPS. So the aggregate effect of adding the EVR would be to increase the mean time between failure of the whole system, which is a big plus.
Okay. This one is from Mervyn. Is there a rule of thumb on how large the regulator needs to be upstream to the UPS?
we would match the size of the EVR to the load rather than using the UPS size. So we'd have to look at the load.
Wasn't there an efficiency where typically they oversize the UPS often for redundancy? And
well, you're never going to purchase a UPS to match the load. You're going to oversize it for expansion or whatever it may be. So when we look at an application, we're going to try and match the load. We don't have any reason to oversize unless there's a need to.
We have another question from John. Is or can the auto transformer switch be incorporated into the EVR?
Auto transfer switch. Yeah, that's something we could certainly look at.
Yes.
Yes.
And our EVRs are so customizable that pretty much whatever a customer wants as far as size.
I mean, that's a point that we haven't made. I mean, a nice thing about being a modest-sized company close to the engineers, we can modify the EVR on a custom basis for whatever the requirements really are.
This one's from Chris. Has there been any system failures in the 900+ installs that we've had?
Our mean time between failure is about 150 operating years. So we've got, as of about 6 months ago, we had about 1,800 operating years and 12 failures during those 1,800 years. So we're talking about 150 years of operation between failures.
We have another question from John. Is there an advantage or disadvantage to also regulating the generator output, or that is, put the EVR in front of the load, which is what we did, right? So,
if I understand the question, we would typically not put ourselves in a position where we're regulating generator power. Generators have their own regulators, and so we're typically put in a system where we're regulating utility power only.
okay, good answer. All right. What's the other question? What other applications or businesses have you used your products in?
Applications, medical, oil and gas, bottling plants, and again, these are both domestic and international sites. As I mentioned in the presentation, we've done a fair amount of work with the State Department and embassies throughout the world. Automotive, if you think about it, it's any process or manufacturing site that has significant cost associated with downtime that can translate to payback for this type of a device. So, you know, high production automotive environments, bottling plants, things like that are all good applications for us. Oil and gas, where you have critical operations. Medical, where you have scanning devices, all good applications for our product.
And then I've got one last question referencing size. What sizes of the units?
Sizes. Yeah, as I mentioned, we typically run from 5 kVA to 2,500 kVA, and we can do voltage at any level of 600 volts or less, 50 or 60 hertz.
And Christopher asked if this is a good application for retail, like Costco and Home Depot. So point of sale, I think, is the reference there, which would be maybe where the minis would apply.
Perhaps minis, depends on single-phase or three-phase applications. I would lean more towards You know, if you're looking at warehousing for those facilities, if you think on a bit of a larger scale, I think you'll find we have a better niche.
Another question, do you consider consumption reductions with reduced voltages in your business case analysis?
In this white paper, we did not. We considered the simply the improved efficiency, and if we would have considered that, the improvement would be for every 1% of voltage reduction, you're going to get a 0.5 to 1% of consumption reduction. So if you're nominally at 100% and you drop the voltage to 95%, you might get 2.5 to 5% of improvement.
Do we have any more questions? Well, I believe that that's all we have for today. Again, we will take questions via the email address or website provided. You can contact Dave at sales@ustpower.com. Visit our website at ustpower.com to download the white paper. There's some other references on there as well. We have some other case studies that might be of interest to you. Feel free to ask us any questions. And as Dave mentioned, the recording and the presentation will be available after today's webinar for you to share with colleagues who might have an interest. Thank you again for attending, and we appreciate your interest. Have a good day.